So we're going to begin the lesson today with some warm-up examples. This is from the previous day. So we want to find the exact value of sine of 225. Now 225, let's first locate it in our Cartesian plane. That's going to be about 45 degrees after 180. So that's 225 degrees. Which, if I draw in my 45, 45 triangle, that'll be -1 here, -1 here, √2 here. Sine of 225 will just be, well, we look at the related angle, the related acute angle, which here is 45 degrees. Take the sine of that, which is opposite over hypotenuse, and we get -1 over √2. For the second one, we have cotangent of 510. Now, cotangent, we know, is, by definition, the reciprocal of tan. So it's as if I'm trying to find tan of 510, and then I just reciprocate that result. How am I going to do that? 510 degrees. Well, first I have to locate 510, which means that I'm going around once, that's 360 degrees, and then I have to figure out how much further I'm going to go beyond 360. So off to the side, I do a little subtraction, and here I get, what is it going to be? So this will become 4, 11, 5, 150 degrees. So 150 degrees past the 0 mark will bring me roughly over here. And this angle that is then traced out is going to be 30 degrees. So I'm using, in this case, my 30, 60, 90 triangle, which is going to be, let's see here, 30, √3, it'll be negative because of the negative x region, 2 and 1. So tan of 510 is, by definition, opposite over adjacent of the related acute angle, which is 30. So tan of 510 equals 1 over -√3. Which means that the reciprocal cotangent of 510 is going to be the reciprocal of my tan ratio, which is just -√3. And finally, for secant of 300, -300 that is, I know that by definition is 1 over cosine of -300. So let me locate -300. So if this is 0, that means I go back clockwise to this point here, which, well, if it's back 300, that means I have 60 degrees as my related acute angle. So I'm looking at my 60, 30, 90 triangle, which will then become, let's see, let's label the sides here. I get 1, √3, and 2. By definition, secant of 60 is adjacent over hypotenuse, and so that's the secant of, so that's cos of -300 is going to give me 1 over 2, which means that secant of -300 is equal to 2. Again, I'm just writing in the reciprocal in this case. Let's look at the sine law now. Now the sine law is, this is a review from grade 10. We have two versions of it. Really, it's one version, just depending on how you want to solve the triangle, or what it is you want to solve, whether it's a side or angle. You can use one of the two versions, but really all you have to do is memorize one. Now with the sine law, you need to have two angles and a side. So you can have, for example, angle A and angle C, and say angle B. Or you need to have two sides and an angle, but one angle with opposite side. So what that means is you have to have a pair. So this is a matching pair. If I had angle A and side A and any other piece of information, then I could use the sine law. So in its statement, we want to solve for the sides. We usually begin the sine law by putting the sides in the numerator. And again, this is from grade 10, sine B, and finally we have C over sine C. And similarly, if we want to solve for angles, we just flip it around. And solve for the angle. So let's look at this in an example. Here in example number 1, we want to solve for the two unknown sides. So let's start off with, which side should we solve for? Well, the one unknown side over here is side A, and we have side B. Now as it stands, I can't really use the sine law because I don't have a angle and corresponding side. I have an angle but no corresponding side. I have a side but no corresponding angle. However, I do know that the sum of the angles in a triangle add up to 180. So angle C can be figured out easily. All I do is subtract from 180 degrees 34 degrees, as well as 50 degrees. That yields, let me see here, that yields 96 degrees. So I get 96 degrees for angle C. Angle C is 96. Let me sneak that into my triangle here. And now I have a matching pair. I have the 54 and the 96. So to set this up, some space. To set this up, I'm going to rewrite my sine law with the side I want to solve for. So in this case, let's write in the sides A and B again and write out my sine law. So I have A over sine of 50, which is equal to B over sine of 44, which is equal to, well, that's 34 actually, so 34 here, which is equal to 54 over sine of 96. Now I have to pick two fractions, and I'm going to start off by choosing the first and the last. Make them equal to each other and solve for A. Let's start that. So I have A over sine of 50 degrees equals 54 over sine of 96 degrees. I do some cross multiplication. So I'm going to go A equals 54 times, this comes up here, sine of 50 degrees, and that's all over sine of 96 degrees. Okay, now we need to calculate here. So let's go to our calculator. Bring this up. Let's clear everything here. So we're going, what do we have here? 54 times sine, oh, just calculate this, 54 times, I'll open up a bracket, 50 sine, that's sine, close the bracket, divided by 96 sine equals 41.6. So let's remember that 41.6 is our side. For A is equal to 41.6 units. Side B is solved similarly. I'm going to set that up for you, but I'm going to skip the steps in between. For B, I'm going to take these two fractions, B over sine 34 degrees equals 54 over sine 96 degrees. Anyways, I'll let you do the work. You should end up with B equals 30.4. And that's our value for B in this question. In example number 2, I'm looking for the unknown angles and side. So in this case, I have two sides. I have one angle. Notice that I have a matching pair of angle and opposite side. So if I wanted to say, let me label this B here. If I wanted to solve for, say, angle A, I can use angle A and its opposite side as well as the matching pair I have. So there was the way I would set that up is sine A over 8 equals sine of 48 over 7. Here we can bring the 8 up to the other side. So I have sine A equals 8 times sine of 48 all over 7. Once you do some calculation, let me see what we get here. So 848 over 7. Let's go back to our calculator. Clear this. 8 times 48. Should clear that. 8 times open bracket 48 sine, close bracket, and that is being divided by 7, 0.8493. So let's use that 0.8493 in our question here. 0.8493. I take the inverse of that to give me my value for A. 0.8493. Let's go back to our calculator. Just gotta figure out what that is. Same number. We take our second function, sine inverse, and we get 51 degrees. We'll round to the nearest degree. Sorry, 58 degrees. So that's 58. 58 degrees. So that looks good, looks very promising. 58 degrees, although angle A doesn't look like it's 58. It is indeed. So this is 58. And angle B can be arrived at not using any sine or cosine law, but just subtracting from 180, 58 and 48. So from 180, we subtract 58, and we subtract 48. What does that yield in this case? 106, which will give us 74 degrees. Now for the remaining side B here, I will let you solve that. Okay, you're going to be setting up the equation with b over sine of 74 degrees equals, again, you can take any two corresponding angle side combination you want, but I'll use what was given originally, 7 over sine of 48 degrees. Show your work, solve for b. I'll leave that up to you. Let's now look at the cosine law. So the cosine law is used in two circumstances. The first one is when I have all three sides. In other words, I have side A, side C, and side B. And in that case, I would rewrite that as you're solving for an angle. So pick an angle. Let's say we'll take angle B here. Okay, the cosine law in solving for an angle B is when you have all three sides, you would rewrite it as cosine of B equals A squared plus C squared minus B squared all over 2AC. On the other hand, you would also use the cosine law when you have, for example, two sides. So check mark means I know side B, check mark means I know side A, and I have the angle in between them. Check mark means I know angle C. In a case like this, you would be solving for an opposite side, which is C in this case. The way I write the cosine law for this scenario is C squared equals A squared plus B squared minus 2 times AB times cosine of C. And those are the two versions of the cosine law that we have to work with. Let's apply them now one at a time to example 3 and 4 respectively. In example 3 here, we have a triangle where we're given two sides, 1, 2, and the contained angle. We want to solve for side I. We'll use the version of the cosine law where we want to solve for a missing side. I'm going to plug in the values as well. 5.11 minus 2 times 5. I'll drop the double zeros at the end. 5.11 and cosine of, in this case, what is it, 49 degrees. This yields 25 plus 26.112 minus 51.1 times cos of 49. So what I've done is I've just multiplied all these numbers here together to give me the 51.1. And let me continue in my algebraic work here. I will obtain 51.112 minus 51.1 cos of 49 equals, and this is where I evaluate this here. This is a product of 51.1 times cos of 49, which will give me 33.52, which leaves me with 17.59, and I've done some rounding there. But the final answer is not going to be that. Remember, this is I squared, so the final answer is going to be the square root of 17.59, which is 4.2. And there you have it. example 3, we've solved for the opposite side of 49 degrees. Here in example 4, we are given three known sides, and we have no angles. So what we have to do is figure out one of the angles. Let's arbitrarily just choose angle B here. So I'm going to use my cosine law for angle B. So I have cos B equals a squared plus c squared minus b squared. You'll notice a pattern that this side always matches up with the angle here. So if I were to have, for example, A as the angle, I'd have A at the end and B somewhere in the first two terms. So just keep that in mind when you're using the cosine law to solve for any angle. There's a pattern to the way it's written. So now in this case, I know what A is. A is 9 squared plus 7 squared minus 8 squared. And this is all over 2 times 9 times 7, which yields 66 over 126, which gives me 0.5238. Finally, my answer, I take B to be the cos inverse of 0.5238. And let me see what that yields. 0.5238. Go to our calculator. 5238. Second function. Cos inverse, that will give me 58.4. Let's just leave it at 58 degrees. So B is 58 degrees. Excellent. Write that in there. Now the other two angles, for angle A and angle C, you can use the sine law if you like to solve for them. At least for one of them, and the remaining angle you can just use the 180 minus the sum of the other two. But again, I will leave that as an exercise for you to try out. Here in example 5, I want to solve for the unknown side x, that is over here. Notice that x happens to be a side of a right angle triangle. So that should already indicate to you that you'll probably be using SOHCAHTOA for your final step. Well, let's take a look now. So I have triangle A, B, and C. I know two angles. I can definitely figure out angle B here because it'll just be 180 minus 78 degrees as well as 50 degrees. And what does that yield? Well, here we'll get a 2. No. Let me do that again. I'll add the 78 and 50 together first. That'll give me 128 degrees. I'll subtract that from 180 degrees to give me 52 degrees. So my angle B is 52. Well, that sets us up very well for using the sine law. I have 52 and opposite side of 8. I'm trying to find something relative to the right angle triangle. So I want to solve actually for side A, which happens to be the hypotenuse of triangle B, D, and C. So let's go about solving for side A. Using the side law, I have A over sine of 50 equals 8 over sine of 52 degrees. Sine of 50 goes here, all divided by sine of 52 degrees. What does that yield? Well, let's go to our calculator again. I'm going to have 8 times 50, that is sine, close bracket. This is divided by, what was the other angle? Take a peek here. 52, so 52 sine. 52 sine equals 7.8 roughly. So let's go back to our page. Our A value is going to be 7.8 meters. Well, that's easy because now we can use the 105 and the 78 to figure out this angle here. Angle C here at the bottom. This angle here will be 23, will be 28 degrees. And therefore I use SOHCAHTOA with the 28, this side and side x. So that will be cosine is equal to x over 7.8, which is the hypotenuse. And therefore x equals 7.8 times cosine of 28. Which yields what? Times 28 cos 6.9 meters. There we go. There is our side. Finally, we're at example number 6. We're looking at Mr. Chung, and he's making a triangular garden, as indicated below by the diagram, in his backyard. However, he needs to construct a fence around the garden to keep the rabbits out. So how much fencing does he need? Well, this is a question where we're looking for a perimeter. So we're finding this red is the perimeter of our triangular garden. So what do we have here? We have a base, we have 2 angles. The third angle I can always figure out. I just subtract from 180 the sum of 59 and 72. So 59 plus 72 will yield 131 degrees. And if I subtract that from 180, I end up with 49 degrees. So in here I have 49 degrees. What I want to do now, I need to figure out the other 2 sides. So let's label this side x and this side y. And we'll begin by solving for x. So with x, I'm going to use the sine law because I have an angle opposite side, and I have the side, and I know the angle. So for x, I will begin, I'll write it out, x over sine of 59 degrees equals 3.5 over sine of 49 degrees. Next line, we bring the sine 59 over 3.5 times sine of 59 degrees over sine of 49 degrees. Let's see what that gives us now using our calculator. So 59, 49, 3.5. Let's take a look. 5 times 59 sine divided by 49 sine. We get 3.9, let's say 4. So that is 4 units here. And for our y value, well, we're going to use the y and the opposite angle. So for the y, we have y over sine of 72 equals 3.5 over 4.9 sine of 49, sorry. This comes over here. And at this point, we just continue with our math, solving for y. So let's go back to our calculator. I have 72 sine times 3.5 divided by 49 sine gives me 4.4. So 4.4 is my y value. And if I add up all the sides now, I get my perimeter. X plus y plus 3.5 equals 4 plus 4.4 plus 3.5. What does that give me? 4, 8, 11, 12.1. Again, if you try this on your own, your answer might be slightly off, but that's okay. As long as you're within about half a unit.